Hello everyone, I'm Jeffrey De Lima, one of the member of Triad Linear Legacy. So at this time, we are going to tackle the system of linear equation, but we will focus about Gaussian elimination and Gauss-Jordan elimination. So my topic is all about Gaussian elimination with back substitution and a system with no solution. By the way, this is the continuation of Ruby-Ann report, which is the Gaussian elimination and Gauss-Jordan elimination. So let's continue the report. We are now here in example number 5, which is Gaussian elimination with back substitution. So solve the system of linear equation. But before we proceed to our or how to solve the system of linear equation and on how to write the solution in this equation, let me know first the step by step on how to write, on how to follow the solution in this Gaussian elimination with back substitution. So the first step that we're going to do is write the augmented matrix of the system of linear equation. Number 2, use elementary row operation to rewrite the matrix in row echelon form. The last one is write the system of linear equation corresponding to the matrix in row echelon form and use back substitution to find the solution. So, in Gaussian elimination with back substitution works well for solving system of linear equation by hand or with a computer. For this algorithm, the order in which you perform the elementary row operation is important. Operate from left to right by columns, using elementary row operation to obtain zeros in all entries directly below the leading 1 sub s. So we are now here in example number 5, which is Gaussian elimination with back substitution. So solve this system of linear equation. So the first one is x sub 2 plus x sub 3 minus 2x sub 4 is equals to negative 3. The second one is x sub 1 plus 2x sub 2 minus x sub 3 is equals to 2. The third one is 2x sub 1 plus 4x sub 2 plus x sub 3 minus 3x sub 4 is equals to negative 2. And the last one is x sub 1 minus 4x sub 2 minus 7x sub 3 minus 4x sub 4 is equals to negative 19. If you remember the step-by-step in Gaussian elimination with back substitution, the first step is write the augmented matrix of the system of linear equation. So here in the solution, the augmented matrix for the system is, since x sub 1 was missing, we are going to write 0. And then x sub 2 is equivalent or equal to 1. Plus x sub 3 is equivalent or equals to 1. Minus 2x sub 4 is equals to negative 2. And then equal to negative 3. X sub 1 is equivalent or equal to 1 plus 2x sub 2 is equal to 1, 2, minus x sub 3 is equal to negative 1. So, in the second one is the x sub 4 was missing again. So, we are going to write 0. And then is equal to 2. So 2x sub 1 plus 4x sub 2 plus x sub 3 is equal minus 3x sub 4 is equal to negative 2. So 2 and then positive 4 is equivalent or equal to 1. Negative 3 is equal to negative 3 and equal to negative 2. So follow lang po kayo dito sa ating mouse or arrow na nakikita nyo sa screen. So the last one is x of 1 is equivalent or equal to 1 minus 4x of 2 is equal to negative 4. Negative 7 is equal to negative 7 minus x of 4 is equivalent or equal to negative 1 is equal to negative 19. So that's the first step that we are going to do when we are going to write the solution in this Gaussian elimination with back substitution. The first step is to write the augmented matrix of the system of linear equation. So the second step is use elementary row operation to rewrite the matrix in row echelon form. So we're going to proceed now. So obtain a leading one in the upper left corner and zeros elsewhere in the first column. So here in the step 2, interchange the first two rows. So kung mapapansin nyo po, dito sa open and close bracket ay nag-interchange na po ang first row and then ang second row. So kung mapapansin nyo po dito, on how to write the augmented matrix on a system linear equation, yung 0 and then 1, 1, negative 2, and negative 3 ay mapupunta po siya dito sa second row. And then ang 1, 2, negative 1, 0, and 2 ay mapupunta po siya dito sa unahan, dito sa first row. So, ayan po sila, nag-interchange the first two rows. So, in this second step, meron po din po siyang another step that we are going to follow. So, here in the second open and close bracket, adding negative 2 times the first row to the third row produce a new third row. So, ang gagawin po kasi natin dito is to form echelon form and para makabuo tayo ng pivot. So, here, adding negative 2 times the first row to the third row produce a new third row. So, this is the formula of this equation. R sub 3 plus the quantity of negative 2 times R1 is equal to R sub 3. So, para po makompute po natin ang procedure na ito, dito po tayo mag-compute. Dito po tayo mag-base because this second bracket, open and close bracket, ay ito po yung result dito po sa computation ng formulang ito. So, magsimula po tayo dito. So, since adding negative 2, ang gagawin po natin is dito po sa third row, ang sabi po dito ay adding negative 2 times the first row to the third row produce a new third row. So, dito, 2 minus 2 times 1. Okay? So, ito po ang ipa-follow natin. 2 minus 2 times 1 is equals to 0. Okay? So, another one. 4 minus 2 times 2 is equals to 0. Okay? So, another 1 minus 2 times negative 1 is equals to 3. Equal to 3. And then, negative 3 minus 2 times 0 is equal to negative 3. Okay? The last one is negative 2 minus 2 times 2 is equal to negative 6. Okay, so this is the result now. So, unti-unti po nagiging 0, 0, 0 ang nasa baba po ng 1, ang under ng 1. So, mapupunta po tayo dito sa pivot. So, another step that we are going to do is adding negative 1 times the first row to the fourth row produce a new fourth row. So, ang step po natin ay same procedure. But, ito kasi ay nasa third row. tayo naman ay dito na tayo sa 4th row. Tapos, the same pa rin na sa R1, dito sa row 1, dito po. So, dito naman po tayo magbe-base kasi po ito na po yung result ng computation dito sa formulang ito. So, let's start again. So, dito po tayo magsimula sa row 4. 1 minus 1 times 1 is equal to 0. Negative 4 minus 1 times 2 is equal to negative 6. Negative 7 minus 1 times negative 1 is equal to negative 6. Negative 1 minus 1 times 0 is equal to negative 1. Negative 19 minus 1 times 2 is equal to negative 21. So that's the step that we are going to follow when we are going to answer the Gaussian elimination with back substitution. So the next procedure that we are going to do is, now that the first column is the desired form, change the second column as follows. So, wala po itong pinagkaiba dito sa step na to. Kung dito, adding negative 2, adding negative 1, dito po sa kabila is adding 6. 6 times the second row to the fourth row produce a new fourth row. So, magsisimula na din po tayo dito sa fourth row. Sa fourth row. Okay? So, magbabase po tayo dito sa last nating pinag-compute sa result. Dito po tayo mag-compute. So, since 0 na po ito, magsisimula na lang po tayo dito sa negative 6. So, negative 6 plus 6 times 1 is equal to 0. Okay? And then, ang kaibahan po dito at saka dito, because dito po sa R2, dito po kasi R2 na, dun po sa kabila is R1, R1. Dito po is R2 na. Okay? So, kaya po, dito na po tayo magta-times sa R2. Okay? So, let's proceed now. So, naging na po siyang 0. So, another one, negative 6 plus 6 times 1 is equal to 0. Okay? Another negative 1 plus 6 times negative 2 is equal to negative 13. Okay? The last one is negative 21 plus 6 times negative 3 is equal to negative 39. Okay, so that's the result of the second step in when we are going to compute the Gaussian elimination with back substitution. Okay, so the third step that we are going to do is write the system of linear equation corresponding to the matrix and the row echelon form and use back substitution to find the solution. Okay, so proceed now to the another step, the third step. So to write the third and fourth column in proper form, multiply the third row by 1/3 and the fourth row by negative 1/3. Okay, so Okay, so the third step, to write the third and fourth column in proper form, multiply the third row by 1/3 and the fourth row by negative 1/13. So, magbe-base na naman po ulit tayo dito, hindi po dito. Okay? So, 3 times 1/3 is equal to 1. Okay? Since ang minimin po dito ay third row, kaya po dito po tayo mag-base. So, 3 times 1/3 is equal to 1. Negative 3 times 1/3 is equal to negative 1. Negative 6 times 1/3 is equal to negative 2. So, dito naman po tayo sa fourth row. So, since 0, 0, 0 na po yan, wag na po natin siyang pakalaman kasi 0 lang naman po ang lalabas kapag po minultiply po natin. Kaya mag-i-start po tayo dito sa negative 13. So, negative 13 times negative 1/3 is equal to 1. Negative 39 times negative 1/30 is equal to 3. So, this is the formula on how to compute the solution. So, okay. So, the second step, the next step, so the matrix is now in row echelon form, and the corresponding system is follows. So, this equation is row echelon form. So, nasunod po natin ang hinihingi on how to write in echelon form. So, we are now here x of 1 plus 2x of 2 minus x of 3, and then the x of 4 was missing, so is equal to 2. So, x of 1 is missing. So, kung matatandaan nyo po, this equation is back substitution. So, magbaback po tayo. Kaya po, since 0 ito, 0, 0, 0, 0, 0, 0, 0. Kaya po, hindi po siya makakasama dito sa system of linear equation. Ito po yung mga sub, x of 1, x of 1, x of 1, x of 2, x of 2, and then x of 3. Kaya po mapapansin po ninyo, dito po ay nawala na po sila. Yan po yung tinutukoy na mga 0, 0, and then 0, 0, 0, 0, 0, 0, and then the last one is 0. Ayan po, mapapansin nyo. Yan. And then, so the matrix is now in row echelon form, and the corresponding system is follows. X of 1 plus 2x of 2 minus x of 3, and then the x of 4 is 0, so it's equals to 2. So, x of 2 plus x of 3 minus 2x of 4 is equal to negative 3. X of 3 minus x of 4 is equal to negative 2. And then, x of 4 is equal to 3. So, use back substitution to find the solution. So, here now, x of 1 is equal to negative 1. X of 2 is equal to 2. X of 3 is equal to 1. And also, x of 4 is equal to 3. So, when solving a system of linear equation, remember that it is possible for the system to have no solution. If in the elimination process, you obtain a row of all zeros except for the last entry, then it is unnecessary to continue the elimination process. You can simply conclude that the system has no solution or inconsistent. So, dito na po yan sa example number 6. So, this is the this is now the uh this is now the answer of this equation of computation here. So in example number 6, a system with no solution. So solve the system of linear equation x of 1 minus x of 2 plus 2x of 3 is equal to 4. So x of 1, so since this is 0, and then plus x of 3 is equal to 6. 2x of 1 minus 3x of 2 plus 5x of 3 is equal to 4. 3x of 1 plus 2x of 2 is equal to, minus x of 3 is equal to 1. So, the same process, write the augmented matrix of the system of linear equation. So, the augmented matrix for the system is, so, x of 1 is equivalent to 1. Since this is negative, negative 1. And then 2 is equal to 4. So, x 1. So, since this is missing the x of 2, we're going to write 0. So, x of 3 is equal to 1. Is equal to 6. Okay, 2, negative 3, positive 5, and then 4, 3, positive 2, minus x of 3 is equal to negative 1. Is equal to 1. So we are here now in apply Gaussian elimination to the augmented matrix. So this is the same procedure in Gaussian elimination with back substitution, but this is the formula of this computation. So r sub 2 plus the quantity minus 1 times r1 is equal to r2. Okay, so magko-compute na naman tayo dun sa augmented matrix kasi dito is the result of the computation of this formula. So, we are going to add negative 1. So, here are the row 2. So, 1 minus 2 times 1 is equal to 0. The next step is 0 minus 1 times negative 1 is equal to 1. Okay? So, another example. 1 negative 1 times 2 is equal to negative 1. The last example is 6 minus 1 times 4 is equal to 2. Okay? So, that's the step. So, the next step is row 3 r sub 3 plus the quantity of minus 2 times r1 is equal to r3. Okay? So, dito naman tayo mag-base ng computation. Okay, dito sa row 3, which is 2, negative 3, 5, and 4. So, 2 minus 2 times 1 is equal to 0. Okay? Negative 3 minus 2 times negative 1 is equal to negative 1. 5 minus 2 times 2 is equal to 1. Okay? And the last one is 4 minus 2 times 4 is equal to negative 4. Okay? So, malapit na po tayo dito makabuo ng pivot. Okay? So, the next step is this one. R sub 4 plus the quantity of negative 3 times R1 is equal to R sub 4, which is the row 4. Okay, so dito naman po tayo magbe-base. Kasi this is the result of the computation of this formula. Okay? So, R minus 3 minus 3 times 1 is equal to 0. 2 minus 3 times negative 1 is equal to 5. Okay? So, negative 1 minus 3 times 2 is equal to negative 7. And the last one is 1 minus 3 times 4 is equal to negative 11. So that's the result of this computation. So the last step that we are going to do is r sub 3 plus r sub 2 is equal to r sub 3. Okay, so ang gagawin natin ay adding row 3 and then adding row 2. So 0 plus 0, 0, 0. Okay, and then negative 1 plus 1 is equal to 0. 1 minus 1 is equal to 0. The last one is negative 4 plus 2 is equal to negative 2. Okay? Negative 4 plus 2 is equal to negative 2. And then the next step is note that the third row of this matrix consists entirely of zeros except for the last entry. This means that the original system of linear equation is inconsistent. You can see why this is true by converting back to a system of linear equation. So solve the system. So x sub 1 minus x sub 2 plus 2x sub 3 is equal to 4. So this is the same of this 1 because 0, 0, 0, 0, 0. So the x sub 1, x sub 1, x sub 1, and then x sub 2, and then x sub 3, hindi na po natin makikita dito sa part na po ito. Kasi this is x sub 1 is 0, 0, 0, 0. Okay, so x sub 1 minus x sub 2 plus 2x sub 3 is equal to 4. X sub 2 minus x sub 3 is equal to 2. So 0 is equal to negative 2. And then the last one is 5x sub 2 plus 7x sub 3 is equal to negative 11. So because the third equation is not possible, the system has no solution. So that's all. Thank you very much for your the cooperation and listening of my report. So I hope marami kayong natutunan sa oras na ito. So thank you very much. And also this is my co-member in Thrive Linear Legacy.